Hi. To find the integral from 0 to infinity e power minus x square dx, and hence to deduce the formula of half factorial, and hence to find the value of half factorial. Before finding this, let us first integrate this solution. Therefore, we can find half factorial. For this, let us consider first I is equal to integral from 0 to infinity e power minus x square dx. Changing the variable to y, we have I is equal to integral from 0 to infinity e power minus y square dy. Multiplying two equations, on LHS we have I into I square is equal to integral 0 to infinity and integral from 0 to infinity e power minus x square into e power minus y square into dx into dy. As the first variable is dx, we can consider y as a constant term, hence we can write e power minus y square here instead of here. By this we have I square is equal to double integral from 0 to infinity e power minus of x square plus y square into, this is a power m into a power n, that is a power m plus n, dx dy. Here we have a formula from Cartesian coordinate systems to polar coordinate system. To convert this expression, this is in Cartesian coordinate system, we shall convert this into polar coordinate system. Then what is polar coordinate system? In Cartesian coordinate system, the points changes as xy, whereas in polar coordinate system it is of form r comma theta, where r is the magnitude of the complex number and theta is the angle of the complex. Here we have a formula integral, double integral, where r is the range of that function, f of x comma y dx dy is equal to double integral from r f of r cos theta comma r sin theta into r dr d theta. This is the interconvertible formula from Cartesian coordinate system to polar coordinate system. The difference between Cartesian and polar coordinate system is Cartesian coordinate system changes with respect to variables x comma y, whereas polar coordinate system changes with respect to variables r comma theta. Now we can reduce this equation as I square is equal to double integral of, as the angle changes from 0 to pi by 2, that infinity can be reduced as from 0 to pi by 2, and this system remains from 0 to infinity e power minus x is nothing but r cos theta. We have r cos theta whole square plus this is r sin theta whole square into r dr d theta. This is nothing but I square is equal to double integral of 0 to pi by 2, 0 to infinity e power minus, taking r square as common, here we have r square into, the remaining terms are cos square theta plus sin square theta into r into dr into d theta. This term is nothing but cos square theta plus sin square theta is 1. We get I square is equal to integral from 0 to pi by 2, integral from 0 to infinity e power e to the power of minus r square into r into dr d theta. Now we have reduced the integral to some easy form. I square is equal to double integral. For the first integral, the limits are from 0 to pi by 2, and for the second it is from 0 to infinity. Let us only consider this integral first. We have integral 0 to infinity e power minus r square into r into dr. Evaluating the integral from integral 0 to infinity e power minus r square into r into dr. Let us take the substitution for this. R square equal to t, 2r dr equal to dt. Now we have r dr equal to 1 by 2 dt. For r is equal to infinity, we meant t equal to infinity, and for r equal to 0, we have t equal to 0. Now the integral is reduced as integral from 0 to infinity e power, this is minus as it is, r square is nothing but t, instead of r square we write t, and r dr, this is r dr is nothing but half dt, half is a constant and dt as it is. Now we shall consider integral e power t dt equal to e power kt dt equal to e power kt by k plus c, where in this constant we have k equal to minus 1. Now the integral is reduced as half into e power minus t by minus 1 from 0 to infinity. This is minus 1 by 2 into evaluating e power minus t between 0 and infinity. Minus 1 by 2 into e power, and substituting e power minus infinity minus e to the power of 0. E to the power of minus infinity equal to 0, where e power 0 equal to 1. This is minus 1 by 2 into 0 minus 1. This is minus into minus plus 1 by 2. From this we have integral from 0 to infinity e power minus r square into r dr equal to 1 by 2. 1 by 2. Now coming to our original expression, we have I square is equal to integral from 0 to pi by 2, integral from 0 to infinity e power minus r square into r dr d theta. The value of this expression is reduced to 1 by 2. From that, I square is equal to integral from 0 to pi by 2. The integral is 1 by 2 into d theta. This is I square is equal to 1 by 2 is a constant term, and we have integral from 0 to pi by 2 d theta. Also integral x power n dx equal to x power n plus 1 by n plus 1 plus c for n not equal to minus 1. Here we have x power 0 dx, that is nothing but x power x to the power of 0 plus 1 by 0 plus 1 plus c, that is x plus c. Similarly, this is I square is equal to half into integral d theta is nothing but theta from 0 to pi by 2. That is I square is equal to half into, this is pi by 2 minus 0, pi by 2 minus 0, that is I square equal to pi by 4. We got I square equal to pi by 4, and we have I is equal to integral from 0 to infinity e to the power of minus x square dx. That is, instead of I square we can write integral from 0 to infinity e power minus x square dx. This is whole square is equal to pi by 4. It is, we have pi by 4. Now taking square root on both sides, integral 0 to infinity e to the power of minus x square dx equal to under root pi by 4. That is, integral from 0 to infinity e power minus x square dx equal to root pi as it is by root 4 is 2.